Hello everyone, this is a presentation about MutateNN, a tool that enables mutation testing for AI and machine learning compilers that focus on the model compilation with the purpose of deployment on different hardware accelerators. Our tool is built using Python on top of Apache TVM, a well-known AI and machine learning compiler, and supports model build, but also generation of mutants, applying mutations on the graph level of the model, but also at the level of the GPU kernel code, model execution against a specified dataset here in the configuration, but also pairwise evaluation for differential testing purposes against different runs on different devices. So for our use case, we're going to take a pre-trained version of MobileNet v2. We're going to load an ONNX model. Our tool supports file-based models such as ONNX, but also pre-trained models provided by different DL frameworks, such as from Keras and PyTorch. And we're going to build the actual model, load the model and build it. But we're going to also generate two mutants, one related with graph and one related with GPU kernel code. We're going to perform an execution of the model and the mutants against a small data set, and we're going to perform evaluation against previous runs. So our tool supports a number of different mutations. For example, there are a number of mutations related, for instance, to conditional operators and conditional expressions, changes related with tensor operations, such as introduction of transposition layers, etc. So on our case, on our example, we're going to take two mutations, one related with transposing some tensors before convolutional layers, and one with changing conditional statements from less than to less than equal on the kernel, on the GPU kernels. Of course, our tool supports a much broader variety of mutations and can be found on GitHub, actually in the configuration. Actually, the whole code base of MutateNN is publicly available on GitHub. So without further ado, we have set our mutations and we're going to perform a run. So we can perform a run right here, and the tool is going to build the models, the original model and the mutants. For the case, in order to speed up the process, we have already generated over here the models. We have compiled them. Each star file corresponds to a specific model compiled, and we're going to use them in order to deploy them actually to the GPU, to the Intel GPU, and then execute for the dataset and perform the evaluation. So I'm going to cut the actual build as we have already them built beforehand, and I'm going to enable the execution. So for the execution, we can see that we have a dataset. So I have a dataset over here. We have some dataset definitions with some folders. We're going to take a small dataset with 5 images for the sake of simplicity. I have enabled the execute flag, and I'm going to perform the run. And as I perform the run, I can go in the folder structure of our tool, and we can see that right now our tool has generated the runs. So if I go, we can see that we have different executions, and this corresponds for each run. And let's say that we go for the drums image. So for the original model here, it has performed a run for the drums image from the dataset, and we can see that the top prediction is 541, which corresponds to the drums label in ImageNet. It's with 0.48 certainty, and we have the top 5 results here along with the execution time. So this is done for the original model, for each one of the images of the dataset, and for the mutants. So now we're able to evaluate it. So we enable the evaluate flag, and what it's going to do is when we run it, it's going to take each one of the previous runs and our run, and it's going to perform a pairwise comparison. So as we see it, completed it here, we had some previous runs on different folders, and we can see that the evaluation generated some files, that the file contain, first of all, comparison, mutation-wise, but for each one of the devices. For instance, for the less than to less than equal case mutation, we can see that device 1 with local, they have 100% similarity. But if I go down here, we can see that there are other devices, but this case might not be true. For instance, our local device with the device probably had 60% similarity only. And in addition, our tool contains comparison for the same folder. So if I go, for instance, in local, we can see that we have comparison against the original model and the mutants. Thank you very much for your time, and I wish you all the best.